Wow, take a look at that one. Well, like I always say, it's a good idea to estimate first of all. So what controls the numerator is essentially that term. And that, if you reduce it, is just an n. What controls this is n cubed. If you have n over n cubed, that's 1 over n squared. 1 over n squared converges. That's a p-series. And it converges. So I'm pretty sure that this one will converge. So let's take a look. If you compare, there's the original, the square root of x squared plus 7 divided by, all right? And then compare that to x squared. Let me have this just go out to 10, let's say. And then you look at the two. So one of them is below the other one. And it seems that they're almost identical. So if I trace, let me go over here where it's a little more obvious. So the bottom one, the one that's below, is actually our monster function right there. The one that's above is 1 over x squared. So is our function oops, I used an x. So I'm going to go ahead and use x's so I don't have to make an ugly right there. So is our function less than or equal to 1 over x squared? So I'm using the comparison test. The comparison test says if you can show that yours is less than or equal to somebody else's and the other one converges, then your series converges. It does say it needs to be bigger than 0, but all of these numbers are going to be positive since n is starting at 1, so it's the 0 we don't have to worry about. Alright, then we need to find out what values of x this is true for. So I could cross multiply, so I'd have x times the radical, x squared times the radical. When is that less than or equal to x to the third plus 2x squared plus 1? And then in order to get rid of the radical, square both sides. So on this side we would have x to the fourth gets multiplied with, in parentheses, x squared plus 7. On the other side we're going to have to multiply it out. X cubed plus 2x squared plus 1 times an x cubed plus 2x squared plus 1. Okay, so on this side we've got x to the 6th plus 7x to the 4th. On the other side, multiply this out, we've got x to the 6th plus 2x to the 5th plus an x to the 3rd. Now multiply this term out, so this and this would make x to the 5th. There's going to be 2x to the 5th. There's going to be, oh, I guess that would go, I thought I could line them up, but this guy is in the way. That's alright. So you've got this one times the middle, so 4x to the 4ths. And this one times the last is 2x squares. And then for the last one, it's going to be 1 times all of this, so there's going to be an x to the 3rd. There's going to be 2x squared and 1 times 1. Who's afraid of algebra? Oh look, x to the 6 and x to the 6 would cancel. And in fact you could move this 7x to the 4 over here. So let me cancel these and subtract 7x to the 4th. Subtract 7x to the 4th. And what remains? We've got positive, 0 over here. We've got positive 4x to the 5th. For our x to the 4, we've got negative 3x to the 4s. For cubes, we've got 2 of them. And for squares, we've got 4 of them. And then there's the number plus 1. Alright, so the question is this polynomial positive from some point on? And I can confidently say yes to the answer because this is what controls it, x to the fifth. And if you've got something like a 12 in here, 12x to the fifth is going to trump 12x to the fourth, and so this positive term is going to dominate the whole thing. So then we could verify 4x is to the fifth minus 3x is to the fourth plus 2x is cubed plus 4x is squared plus a 1. And then we need to know, starting actually at 1, so from 1 on, or actually from some point after 1, is it true that this polynomial is positive? So I need to be able to look at negative and positive values, so maybe I should just go from negative 10 to positive 10. And, oh yeah, x to the fifth dominates this thing from the very beginning. It never even lets it be negative at all. So, that means that this inequality is true, and so it passes this. So we have n squared plus 7 in square root over n cubed plus 2n squared plus 7 is less than or equal to 1 over n squared. So that's for all n's bigger than or equal to 0. And that means that it's also true for the sum, as it goes from 1 to infinity. Sum n equals 1 to infinity. And then this one is a convergent p series, the p being the exponent. Since the exponent is bigger than 1, it converges.